or hypoparathyroidism, after you have this IV injection of this bovine PTH, you find that the levels of the CAMP, you measure the level of the CAMP, you find that they're far much lesser, urinary level of CAMP, to be precise. You find that the levels are going to be less in pseudo-hypoparathyroidism as compared to hypoparathyroidism. That is the first one in the diagnosis of pseudo-hypoparathyroidism. Then we have in thyroid disorders. In thyroid disorders, we find that the levels of CAMP are far much less in hypothyroidism compared to thyrotoxicosis. Again, the levels of CAMP are far much less in hypoparathyroidism compared to the levels of CAMP in thyrotoxicosis. Those are the plasma levels. When we're talking about pseudo-hypoparathyroidism, we're talking about the urinary CAMP levels. I have to make mention of this. Then when we're talking about the thyroid disorders, we talked about plasma CAMP levels, that they are less in hypothyroidism compared to those in thyrotoxicosis. Then in malignant disorders, we find that if CAMP is added, we find that the malignant cells go back to normal and cell growth is reduced. So we've talked about diagnosis of pseudo-hypoparathyroidism, thyroid disorders, malignant diseases. We have the fourth one, which is the differentiation between extrahepatic obstructive jaundice as well as intrahepatic cholestasis. In this case, we find that we have to do an IV. Please mute yourself. Thank you. There's feedback coming back. There's feedback coming back. If you could mute yourself, Madam, please. The fourth one that, yes?
I've got a question. What's the difference between pseudo and idiopathic?
What's the difference between pseudo and
idiopathic?
So you tell me, what's the difference as a medical personnel? I'm a biochemist. You tell me, what's the difference between pseudo and idiopathic?
I think idiopathic, it means maybe something, there's a clear way of knowing it, but for pseudo, I'm not so sure.
No, pseudo is just the opposite of that.
All right.
Isn't it? Anybody else who has something to say? Remember, I said my classes are highly. Was that Ruben? Was that Ruben?
No.
No, it was Prince.
Who?
Prince.
Sorry, who?
Prince, madam.
Oh, okay. Okay, thank you very much, Prince. Where was I? My brain was moving in one direction. Okay, so we talked about the diagnosis of pseudo-hypoparathyroidism. We talked about thyroid disorders. We talked about malignant diseases. And the last one we're looking at was when we're looking at jaundice, extrahepatic obstructive jaundice, as well as intrahepatic cholestasis. So in this case, we find that if we have an injection of glucagon, the plasma levels of CAMP are going to be increased in extrahepatic duct obstructive jaundice compared to those in intrahepatic cholestasis. So the reason why we're looking at these nucleotides, again, in this case, when we're looking at CAMP, you can be able, just by looking at measuring the levels of these nucleotides, CAMP to be precise, you'll be able to differentiate between a number of disorders. These, of course, there are even more, which I would appreciate if you do some reading and put some more, because what you learn here and what you're going to meet in the field is going to be totally different. You might end up meeting certain disorders or which you haven't learned about, but you have to do more of the reading as well. Okay, so Prince, just a quick recap of what we've looked at. What did we start with looking at?
Sorry, you mean from the top?
Yes, we started looking at, we introduced nucleosides, isn't it?
Yes.
And you talked about their structure, how they are formed, so their basic properties and their functions, what they are used for. Like we are right now on camp.
Yes, thank you so much, Prince. So we started looking at the nucleosides. We mentioned what they are. Then we said when we just add the phosphate group, we have nucleotides. Then we came to the nucleic acid. Then we looked at each of the components. Yes, as Prince has. It is actually very vital. For example, the formation of the hydrogen bonds, isn't it? Because it's the very backbone of the formation of the double nucleotides, what role they play in the body, which I did say that you understand more when we come to look at the metabolic pathways. And from there, we also look of CAMP can be able to help you to differentiate in different disorders. Then afterwards, we're now coming to look at nucleoside analogs. Does anybody have an idea of what?
Yes, analogs.
Nucleoside. What is a nucleoside?
Yes.
An analog. What does the word analog mean?
Says Ruben. An analog can refer to. It's Ruben. So an analog can refer to. Yes, it can refer to a chemical substance that is identical or nearly the same as with the composition of a certain nucleoside.
Yes, exactly. So, Ruben, thank you so much. So, when we're looking at nucleoside analogs, we are looking at what, Ruben? Now, bring it back to nucleoside.
For
Anybody
instance,
else
we
who
are
can
looking
come
at,
on board?
Yes, this is Ruben. For instance, if we are looking at a nucleoside made from uracil,
Yes.
Uracil has got an analog which is 5-bromouracil, which can replace it and act as if it is uracil, but it's not.
Okay, thank you so much. So when we're looking at nucleoside analogs, we're just looking at they resemble naturally occurring nucleosides, but they have their structure modifications, as Ruben has rightly said. So where are these nucleoside analogs used? In therapy. Do you have an idea? Not Ruben. I need a female. No female has spoken ever since we started. Are there any females on this group?
Yes.
Ruben, am I there?
Yes.
Oh, okay.
Yes, madam, you're allowed to be.
Do you have any idea
Okay.
where these nucleoside analogs are used? I must be doing a very crappy job. I've not managed to remove even one female out of her shell today to speak. Am I that bad?
They
I've only managed to
nice.
work with the boys.
Madam.
Yes, your name, please.
They participate in biosynthetic processes.
Yes, brilliant, brilliant. Only I didn't get your name.
Priska.
Okay, great. Thank you so much, Priska. Yes, they take part in the biosynthetic uh, processes, isn't it? How these analogs work. Yes, you can go ahead. Is that Priska? Can I have a female to come in on as well? The boys have been talking a lot. Anyone? You know the story of everybody and nobody. Yes, Juliet. Juliet, you can go ahead. Ruben, am I there?
Yes, we can hear you and see the presentation.
Okay, thank you. So there are basically three things that these nucleoside analogs can do. The first one, remember, is a nucleoside analog. So it basically should take part in what a nucleoside does, isn't it? So the first one is incorporation into the viral nucleic acids. So when this nucleoside analog incorporates into the viral nucleic acid, what do you think will happen? It will lead to disruption of the biological process that take place there, because they have that modification that is it Priska did mention. Then we have as well interaction with vital enzymes. Remember, when we were talking about the biological importance of the nucleotides, we did mention protein synthesis. We did mention transcription somewhere. So when these nucleoside analogs interact with the viral, with the vital enzymes, such as the polymerases, the methyltransferases, the kinases, and so on, they are going to disrupt these metabolic pathways in which these enzymes are supposed to take part in. That is the whole idea of having these nucleoside analogs. They're supposed to insert themselves, incorporate themselves, and then disrupt the process that's supposed to take place there. Then these nucleoside analogs also have anti-cancer properties, and they are cytotoxic. We have to make mention of this cytotoxic, especially on the liver. So what happens is that when a nucleoside analog is ingested, the first thing, remember, it's a nucleoside. If it's a nucleoside, it means it doesn't have the phosphate group. So what needs to happen is phosphorylation by the kinases has to take place. So we did mention where either viral infection or cancer, it doesn't matter which one. But whichever way it is, phosphorylation needs to take place. After phosphorylation takes place, what do we form from the nucleoside? Anybody? What? Phosphorylation of a nucleoside. But where are the ladies? What's wrong?
Madam.
No, can you not be backbenchers? Then we complain and say that the gents are leading, that we are discriminated against. Can we be active? Can we stop sleeping? It's not only the men in this class. I said it's a teamwork. Nobody is going to laugh at you if you say anything. I like the way Isaac, Dominic, Tumelo, Sanford, Prince, Ruben, and Priska have been coming out, especially the guys. They've come out and they are not afraid to say what they have to say. It's a teamwork. Whatever it is that you have to say, people need to listen and need to hear what you have to say. Remember that. If it's a mistake, we all learn from the mistake. But it's through trying that you get better. Not just folding your arms and listening and say, no, you're an active member of the class. This goes out to all the females here. And that question, I posed it in such a way that anybody can answer that, hoping that a female will jump on board. Dominic, am I not saying the truth?
Yeah, yes, madam, you are saying the truth.
But why are the ladies quiet? Are they always like this?
The
No,
letter
they
talk.
don't.
They actually talk.
Or it's
No,
because I'm
madam,
a female?
they speak. I don't know what's happening. Maybe.
Madam, beat them.
Please, I need the ladies to come on board as well. We're moving together. Okay. So after the nucleoside has been phosphorylated by the kinases, we have a nucleotide that has been formed. Then that nucleotide, remember when we were talking about what happens when we say that it can incorporate into the nucleic acid, or it can inhibit the different enzymes, either the polymerases or reverse transcriptase in the case of HIV, or the nucleoside converting enzymes. But whatever is the case, the nucleoside analogs, the main objective of them is to disrupt the metabolic pathways that are taking place there, so as to get rid of the virus, the bacteria, or the cancer that is there. Okay, so we come to look at the HIV genome and structure. We cannot not look at this HIV genome and structure when we're looking at nucleoside analogs. You will read this. I hope everybody is listening. On this one, I will not talk, but the questions that are going to come in your CA are going to come from this. So you need to remember that there are 9 genes, but there are 3 main important genes that are there: GAG, POL, and M. GAG, POL, and M. So M is mainly concerned with the envelope proteins. POL is more connected with the polymerases, the enzymes, and then you have the group antigen. Also, but you will read more on this one, and the question in the CA I've given you a leakage is going to come on this enzyme genome and structure of the HIV. Okay, are we clear on what I've just said? I'll say it at the end as well. Then we were saying when we're looking at these nucleoside analogs, we can look at the example of HIV. We know that the drugs that are given is the HAT, highly active antiretroviral therapy. So this HAT usually consists of 3 different drugs, where you have 2 nucleoside reverse transcriptase inhibitors. When we're talking about a nucleoside reverse transcriptase inhibitor, we're just talking about a nucleoside analog. In this case, it inhibits the enzyme reverse transcriptase. Remember, we said that HIV has 2 single-stranded RNAs in there. So this reverse transcriptase is just to prevent reverse transcription, which is the formation of DNA from there. So you have 2 nucleoside reverse transcriptase inhibitors. You can have either a non-nucleoside reverse transcriptase inhibitor, or a protease inhibitor, or an integrase inhibitor. So remember that your protease, when you are looking at the enzymes on your HIV, you have your integrase, which helps it to integrate into, which helps the HIV entity to integrate into the human genome. And then you have also ways that the protease, which takes part in post-translational processing, isn't it? Which cuts those big proteins into smaller pieces. So when you add a protease or an integrase or a nucleoside reverse transcriptase inhibitor or a non-nucleoside reverse transcriptase inhibitor, nucleoside reverse transcriptase inhibitor. So you're acting on these 3 enzymes. Are we clear on what I've just said now?
Yes, madam.
No, madam.
No, we are not clear.
Madam, kindly repeat on
No,
the enzyme.
I'm not clear, madam.
Okay. So I mentioned you are going to have a CA. In your CA, I'm not going to talk much now about this HIV genome and structure. That is looking at the genes that are there and the important proteins that are there. You're going to read on your own. But this is why your CA is going to be based on. So I'm even giving you a linkage. Not saying that you should not read the other part. Of course, you should read the other part for your knowledge as well. But this is where it's going to come from. My questions are going to come from here. So after that, I did mention to talk about the nucleoside analogs that are used in heart therapy. That is highly active antiretroviral therapy, which is used in HIV. I said that there's a nucleoside reverse transcriptase inhibitor, which inhibits reverse transcriptase. Remember that your reverse transcriptase enzyme is the one that helps in reverse transcription of the RNA into your DNA. So you have 2 of these. Then you can have either a non-nucleoside reverse transcriptase inhibitor as the second drug, or you can have an integrase inhibitor. Remember what integrase does is integration into the human genome. Then you have a protease inhibitor. Protease, you remember what it does, which is post-translational modifications. The exact post-translational modification, reverse transcription, and all this, we're all going to look at them later when we're looking at the metabolic pathways. Here, we're just mentioning what is there, but we're going to explain all this in detail. Are we clear now?
Yes, madam.
Okay, thank you. So this is just what I mentioned just before. We're looking at the HIV, which you will read as well. This is very easy. You read about the cycle of HIV, and you realize the cycles that we're saying, the places where we use our heart therapy, which are the nucleoside reverse transcriptases, which is here, preventing at stage 4, where we're preventing reverse transcription. I've just mentioned this just before on the other side. This is just a different slide mentioning the same thing that I've just already. So I'm talking about the reverse transcriptase inhibitor, the integrase inhibitor, and the protein inhibitors. Of course, there are also capsid inhibitors, maturation inhibitors, and the rest, but our interest is the nucleoside, which are used for reverse transcriptase inhibition. Okay, so this I already mentioned that phosphorylation takes place when it's ingested, and then after that it's incorporated, and then it inhibits the processes that are taking place there. In the case of HIV, it terminates reverse transcription. Remember, it's a nucleoside reverse transcriptase inhibitor, so it inhibits reverse transcription. Okay. But then we find that these nucleoside analogs have to be modified. They have to undergo constant modification because of the thymidine analog resistance mutations in the reverse transcriptase of the HIV virus. These are some of the drugs that have been approved that are nucleoside analogs. We have zidovudine, DDI, temivudine. Of course, you even pronounce. So these are the drugs that are there. Yes. Was that a question to me? Okay, so if you can just mute. Okay, so those are the drugs that I have mentioned that are nucleoside analogs, and which you are going to be actually be prescribing to your patients sometime in the future. But even when you be doing that, you remember from your biochemistry lessons when we looked at nucleoside analogs and how they actually act. That's why we're looking at these nucleic acids today with you. Okay, we've come to the end of our class. We looked at what nucleic acids are. We will not go back and do all those things because we've talked about them already numerous times. My throat is even dry. Then we looked at the difference between the nucleosides and the nucleotides. We looked at the composition of the nucleotides and described each component. We also looked at the biological roles of the nucleotides as well as the clinical application of CAMP, where we're looking at measuring of. Yes? I can't hear you. Yes, I've seen the time. I'm just winding up. Don't worry about it.
Madam,
Just winding up. I know it's supposed to have another class.
Madam, I've got a question.
Okay.
Hello.
Yeah, I was
Madam.
asking,
Yes.
I'm asking,
You are breaking. Type your question. I can't hear you properly. Please type your question.
yeah, so what is the biochemistry, related to the issue of the post-exposure prophylaxis and the pre-exposure prophylaxis? Yeah, so how is the, yeah, I'm asking what is the biochemistry behind the issue of the post-exposure and the pre-exposure prophylaxis?
So if you remember, this is why I said that I'm going to bring the question on the CA. I said that you do some reading on this one. Even in the beginning, I did highlight it, and even at the end, I did highlight it, and I said my questions are going to come from this particular component where we're looking at the nucleic acid, the nucleoside analogs. So I said I'll not talk much on this one, but I'm giving you a look at this is where your CA is going to come from.
Madam, I've
Are
got
we
a question.
clear? Yes.
Yeah.
Oh,
So
Madam,
like,
good morning. I just wanted to clarify.
let me first talk. Yes. So like when you look at the same nucleoside analogs, like their usage. So like, is there any chance, like, for example, we talk about the protease inhibitor. Is there any chance that they attack the real DNA that you're supposed to look at, or the post-translation of the normal proteins that we need, or maybe they just attack the viruses and the like?
Very good question. But those concerning nucleoside analogs, that's where the C is going to come from. You see, I've been very kind. I'm not bringing from everything that I've taught today. It's just on this one part. So on this one part, this is where you're going to do some reading, and this is where I'm going to base the CA on. You read more on this one. This is just to encourage you to do some self-reading as well, because you need that very much when you finish and you start working. It's not everything that you're going to meet in your practice that you've been taught in school. You will have to do some reading on your own as well. Okay. So I've even included that at the end. This is where I'm going to base the questions on. That is on nucleoside analogs in cancer, then looking at the genetic makeup, key proteins in HIV, and also nucleoside analogs in HIV. This is where the CA is going to come from, the questions from me. Are we clear? Is there any other question?
Madam,
Ruben, Emma?
yes, recommend to use for
I didn't hear anything. Please type because I can't hear. Emmanuel, I've put the books at the bottom. I've put the references here. You'll find them in your slide. Emmanuel was asking about the books that you can use. I've put them here, and some of them are journals. If the class rep can put the email address here, so I will send it to one email. I'll send it to one email, and then you can distribute the journal that I'll send as well, just in case you might not be able to have access to it. So somebody type an email here.
Madam, can you just kindly share the same books on journals with Ruben? I think it would be easier that way.
Okay, Ruben, please give me your email. Oh, I have your phone number. Okay, I'll contact you on the phone. Do I send to Ruben? This is a class rep email, John Peary.
Yes, then also I'm the class rep with John.
Okay, so I'll send the journals to you. Some of them that can't, that you need to have access to, I'll send them to you, and you distribute them to everyone. I repeat again. So we've looked at all this, but as you know, you are now in university, you're not in secondary school. You need to have some level of self-reading. So on the nucleoside analogs, I've put the questions here, what you're supposed to read. This is where your CA is going to come from. But please, what I'm saying is you should not abandon everything else that we are looking at before and just concentrate on this, because you do need to know everything for you to be able to understand your medicine as well. So yes, I'm going to ask this in the CA, but please do read the other part as well. Are we clear, Priska?
Yes, madam, we are clear.
Oh, okay. Oh.
Madam.
And I'll send to John's email, and he'll send to everybody else. I'll upload the note. I'm going to do another voice over. If there are any other questions, anything that you did not understand, please, you can send me a message on Moodle and I'll gladly reply. And again, I apologize that we have to learn in this way. I know how hard it is for you, but believe you me, it's hard for us as well. But let's try to work together and see the best that we can do, you and us, the lecturers, for now.